Hello friends, grab your coffee, grab your cookie, and please do not blow on the cookie too hard because today's topic is paper dust. Yes, the dust that looks soft, innocent, harmless, until it fills your shop like a snowstorm made by a very angry printer. My name is Michael Klepik, and I have spent 15 years working with air filtration systems for paper converting, printing plants, packaging lines, shredders, and recycling operations. Today, I will explain what paper dust is, why it behaves the way it does, and how we safely control it. What paper dust really is. Paper dust is made of extremely lightweight cellulose fibers and small fragments that break off during cutting, shredding, printing, trimming, and recycling operations. Typical particle sizes range from several microns to several millimeters, depending on the equipment. What makes paper dust unique is this. First, it is extremely light and stays suspended in the air for a long time. Second, it creates strong static charges when handled at high speed. Third, it can be combustible under the right conditions. Fourth, fibers can tangle and clog filters if the system is not properly designed. Fifth, dust from printed material may contain inks, coatings, and additives. Paper dust may look soft and harmless, but in the air it behaves unpredictably, especially around machinery with high-speed blades. Where paper dust appears in industry. Paper dust is common in many operations. The most frequent sources include, first, cutting and trimming paper sheets and rolls. Second, high-speed printing and converting lines. Third, shredding and document destruction equipment. Fourth, corrugated cardboard production and slitter machines. Fifth, tissue and napkin converting lines. Sixth, paper recycling plants during pulping and sorting operations. Anywhere paper moves quickly, dust appears. Anywhere blades or rollers touch paper, dust appears even more. Why paper dust is dangerous. Paper dust introduces several risks at the same time. First, it is a respiratory irritant, especially the smallest fragments. Second, it is easily combustible, especially when dry and airborne. Third, static electricity can ignite dust clouds under the wrong conditions. Fourth, dust can interfere with sensors, coat machinery, and cause overheating. Fifth, buildup on motors or electrical panels increases fire risk. Even thin layers of settled paper dust can ignite if disturbed and mixed back into the air. How I capture paper dust? At the source. The key to controlling paper dust is capturing it exactly where it forms. Because the dust is so light, it escapes easily unless the hood design is correct. The best capture methods include: first, enclosed hoods around knives and slitter sections. Second, pickup points placed directly at shredder blades. Third, side draft hoods along converting lines. Fourth, enclosed conveyor transfer points. Fifth, multi-point pickup inside recycling and sorting machines. For paper dust, I designed duct velocities from 4,000 to 5,000 feet per minute. Anything lower allows fibers to settle and eventually block the ducts. What filtration equipment works best? Paper dust has different behaviors depending on how it is generated. Here's how I choose the right collector. For dry, fine paper dust, I often use a faux EHN cartridge dust collector because, first, it handles small, dry particles extremely well. Second, it offers large filtration area in a compact design. Third, it has efficient pulse cleaning for lightweight dust. For fibrous or fluffy paper dust, fibrous dust tends to mat and tangle. For these situations, I prefer a Baghouse Blizzard. First, it tolerates irregular and fibrous particles. Second, it provides strong airflow even under heavy load. Third, it is easy to maintain and clean for combustible paper dust. Because paper dust can be combustible, I often add, first, explosion vents sized for the collector. Second, anti-static filter bags or cartridges. Third, proper grounding and bonding of all equipment. Fourth, a spark detection or spark arrestor system for shredders. These additions ensure safety and compliance. Static electricity, the silent problem paper. Dust generates a surprising amount of static electricity. Here is what static does. First, it causes dust to cling to surfaces instead of entering the filter. Second, it interferes with airflow and increases dust buildup. Third, it can ignite airborne paper fibers. Fourth, it disrupts sensors and control electronics. To eliminate static issues, I always include, first, grounded ductwork. Second, anti-static filter media. Third, bonding between all components. Fourth, proper humidity control if the environment is extremely dry. Static control is essential for stable operation. The most common mistakes I see with paper dust. Here are the mistakes I encounter most often. First, using duct velocities that are too low for lightweight fibers. Second, allowing dust to mix with metal or plastic dust in the same collector. Third, ignoring combustible dust requirements. Fourth, not enclosing cutting and trimming areas. Fifth, failing to ground equipment, causing static shocks and dust adhesion. Sixth, undersized filters that clog quickly under fibrous load. These issues reduce efficiency and create serious hazards. What I always do on paper dust projects. My approach includes, first, identifying whether the process generates fine dust or fibrous particles. Second, designing high duct velocities specifically for lightweight dust. Third, using fully enclosed hoods on cutting sections. Fourth, selecting the right collector type for the dust characteristics. Fifth, including explosion protection when needed. Sixth, adding anti-static protection across the entire system. Seventh, ensuring proper discharge systems for fluffy dust. These steps guarantee stable operation and long equipment life. Paper dust may look soft and harmless, but it is lightweight, airborne, full of static, and potentially combustible. With proper airflow, enclosure, static control, and the right filtration system, you can handle it safely and efficiently. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, the only paper that should fly in your facility is the paperwork, not the dust. See you in the next video.